Everyone, welcome to the video. Today we are going to solve count digit groupings of a number. In this question, we are given a string, okay, which contains the integers. Now we have to return valid continuous subarrays. We have to return valid continuous subarrays in the given array S, where each subarray sum is in non-decreasing order. So, as you have seen, I have taken this as an array. So, because we'll use bifurcations, okay, index bifurcations, and we will consider and solve this string by taking it as an array. So I will reiterate, we have to find the valid continuous subarrays in this given array S, where each subarray sum is in non-decreasing order or increasing order from left to right. Okay, from left to right, from left to right, 1, 2, 9, 1, 11, 1, 11, 19. So as I mentioned, it is non-decreasing order, but can be same order also. As you can see here, the highlighted one, the first two sub arrays have same sum or digit sum, but the third array is obviously greater than. But it can be, let's say there are, the input array is 1, 1 and 1. In that case, all the three sub arrays can have some 1, 1 and 1, and it will be fairly complete. To begin with, I will import first of all LRU cache in order to add the memoization. I will not use it in main function, but I will create a utility function where I will use it and it will become very handy. Okay. So first of all, I will store the length of this given string, and similarly, I will initialize the DP. I will initialize the DP of length n cross n, and which I calculated moments ago, which is the length of the string. Okay. So I have created an initializer DP with filled all with zeros. Okay. Now I will fill this DP. Let's say how it goes. So for I in range, I will use here dependent loop, so that since we have to take care of the previous sum of digits also, previous digit sums also. Cool. Previous digit sums. Okay. So in that case, the dependent loop will start from I and go to n. Okay, go to n. Because see, if you have to take if you consider the previous subarrays, okay, you'll have to be dependent. The second loop should be dependent on the first loop, so that you get the condition where when you started from some point and you have reached at the current point. Okay, now there are two conditions. If I is equal to j, if I is equal to j, I will assign the value of element at index j to the db, element at index x, but I will typecast it to integer because it is in string format. It is in string format and we are dealing with integers. If that's not the case, if I and j are not same, which means they are not the same digits, in that case, I will calculate the sum of the element from I to j. I will calculate sum of the element from I to j, I to j in the given string s, and assign it to dp. Okay, and also I will store this current current integer of this string. Now, this was our main function. So as you can see, I've calculated the sum. If both the digits I and j are same, align the value of this character at index j to the dp. Otherwise, assign the character at index j in integer format along with the sum from I to j. Sum from I to j. Here I will use my memoization cache, LRU cache, to memorize the utility function. Okay. I will define a utility function which will have two arguments, previous number and I. Okay, previous number and I. To begin with, to begin with, this will start from a place where, okay, now the parameters will be the previous number and current number, both will be zero. I is the current number, previous is the previous number. Let's say previous number. Okay, now here in the parameters, the since when we are beginning, previous number is nothing, which is zero, and current number is nothing, which is zero. Okay, let's start our function. There are two conditions. First of all, base, if I is same as n, if I is equals to n, if I equals to n, this will mean we have reached the end of the array. We have reached the end of the array, so it will return 1, which is again the 1 again will be a valid sub array. Okay, now return 1. Okay, now I will initialize a result variable res to store the cumulative result. Okay, now I will iterate for all ending indices. I'll name it x. Okay, so for x in range I to n. What am I doing over here is I'm iterating over all possible end indexes x for the current subarray starting at the current index I, starting at the current position I, starting from I to all the indexes. Now I will check. Now I will check if the sum of the current subarray, the sum of the current subarray from I to x is greater than or equal to the previous number encountered. If the sum of the current subarray, which is dpix, is greater than or equal to the previous number encountered. Previous number is previous sum of digits of previous number. Okay. And now, if this is the case, if it is greater than or equal to, okay, then recursively again call the utility function with the updated previous number and current number. Okay, the previous number will become what? Previous number will become the current number. Previous number will become the current number, and the current will become x plus 1. We were at I, but currently since we are traversing using the index s, then x plus 1 will be the next one. Okay, next one. And at the end, we will return the total result. Total result. Let me submit it. We have already passed the argument and called our utility function. Yeah, it did the job. It did the job in pretty less time. Otherwise, if I had not taken this memoized LRU cache, which is enabling memoization for the utility function, in that case, it would have taken much more time, or it would have given TLE. So I will just brief you what this LRU cache does is. So it will store the previous result, and when we are successively calling the next iteration of our recursion, it will use the result of previous calculation in order to facilitate the next iteration, next recursive iteration. So I hope you learned this concept and enjoyed it. Thank you. Have a nice day.